we have this circuit, 4 resistors, and you see the values there. What I want you to do is pause the video and calculate the total resistance. Okay, good. You paused and you did it. What did you get? Let's work through this problem. You have this 1.5K ohm. It's really 1,500 ohms, right? You have 700, 300, 150 ohm. What you need to do, start working from the far end, away from the source, okay? So what you do, take these 2 resistors, and they are in parallel. Calculate the equivalent resistance of them. So we have them here. This is R3, which is 300 ohms. I'm not going to put the ohm sign so that it doesn't crowd the screen too much. Alright, I'm not going to put it here. You have 150 ohms. Now, let's call this R3 in parallel with 4. R3 and 4 in parallel. Now, you know that the formula for calculating 2 resistors in parallel is 1 over RT equal 1 over R1 plus 1 over R2 plus 1 over R3 and so on and so forth. So, 1 divided by the equivalent resistance of R3 and R4 is equal, or R3 and R4 in parallel. We're going to find the equivalent resistance of that. This is equal to what you're going to, let me rewrite this. So let's say R equivalent of 3 and 4. Let's call it that. Right? Because I don't want to have any confusion about REQ1 in parallel. What is it we're finding? So we're going to calculate the equivalent resistance of R3 and 4 combined. Remember, this is R3, this is R4. This is equal to 1 divided by 300 plus 1 divided by 150. So 1 divided by the equivalent of 3 and 4 together combined is equal to 1 over 300. Let's go to our calculator and work that out. Calculator. Alright. So we have, let me get it smaller. We have 1 divided by 300 equal that, okay, plus, use bracket for safety, 1 divided by 150, close bracket, equal. Alright, so that's what we have. I could also have done it like this. Open bracket 1 over 300, close bracket, plus, open bracket, 1 over 150, close bracket, equal. Alright, what we have is 0.01. 0.01. Alright, now this you can write it as 0.01 over 1. So after that, now if you say 1 over this equivalent resistance equals 0.01 divided by 1, what you could do is find the reciprocal of both sides. Or if you want, you could cross multiply. You'll get the same thing. But let's practice finding the reciprocal. that would be the multiplicative inverse of both sides. So you invert both sides. So 1 over REQ becomes REQ over 1, which is just REQ. You don't have to put the over 1. Equal 0.01 divided by 1 equal 1 divided by 0.01. Look at this. What is 1 divided by 0.01? Well, if you want the denominator to become 1, you have 0.01 multiplied by 100. And what happened under here is that you have a 1. But the 1 up top times 100 will be 100. So, the equivalent resistance of 3 and 4 combined is equal to 100 ohms. Alright? So, that's the equivalent over here. So, let's redraw the circuit and continue. So, what we have is our source. We have our R1 and our R2, and then we have the equivalent of R3 and 4, and that is 100 ohms. Alright? Now, R1 is 1.5K. Let's write it out as 1500 ohms. What was R2 again? R2 was 700 ohms. So that is 700 ohms. Now, what you really have are 3 resistors in series. So you can just go directly to RT, total resistance. RT equals. So remember, they are in series, so you just add them. 1500 plus 700 plus 100. Now, this is going to be 1500 plus 700 plus 100. 0 plus 0 plus 0 is 0. 0 plus 0 plus 0 is 0. 7 and 1 is 8. 8 and 5 is 13. Now the 3 carry 1. 1 and 1, 2. So we have 2300 ohms as the total resistance. So therefore, RT is equal to 2300 ohms. Let me write it up here. So, what we get for RT? RT is equal to 2300. Let me just write everything in black since I had it mostly that color. So RT is equal to 2300 ohms.